in the battery though.
Okay, good evening, everybody. It is Friday night. It's March 8th, 2024. Welcome to the League of Extraordinary Inventors. I'm your host, Mike from Inventors Research. And also online tonight, we have Gerald live from Manitoba. He's on the line with us tonight. How's it going, Gerald?
Pretty good, Mike. Hey, everybody out there. How are you?
Yeah, we're doing good. It's been a busy week. I've been ordering. I've been ordering parts and got some new ideas lined up for the next week. So I'm gonna build some transformers. I'll get into that a little bit later. I know you've been working pretty hard on this new heater system, which seems pretty intriguing because of the fact that it only works it's DC powered and it's solar powered. So maybe we could touch base on that a little bit. Also,
Absolutely.
It's open lines tonight, everybody. So live chat is open, and also the link is for the show as well. So if you want to join the show, just make sure you have a good microphone, webcam, and you can join the backstage. I'll let you in, and we'll make it a good conversation. Usually our shows go for about 2 hours. We'll start with Gerald. So this week you've done some changes, more testing with that heater system.
Yeah, sorry, I'm trying to set up a small demonstration here. My camera's not really set up for it though, but actually I've done quite a bit. If I'll show the audience in a minute or two here, but
but
the little heater that I got going on now. Go ahead.
You've been working on this for what few months now?
Yeah, about a month and a half, 2 months, somewhere around there. Yeah, I've you know what? My basement's a little chilly. And I was looking for a quick, easy way of running heaters. And I didn't want to use electronics. I mean, I got the whole power inverter and the charge controllers and all that. Yeah. Got the solar panels. But I wanted a quick way to do it so that I didn't have to worry about it, right?
Right.
So it runs on a solar panel. One single solar panel will run 2 heaters. No problem. Yeah, and they're 200 watt heaters on medium, and then you can go to max, and they'll be 300 watts. So then, it's and they're pretty toasty. I'll do a little demonstration in a bit. But
you made a little cooker or something? You made like a little
I was going to say my latest little invention is I took a toaster oven, I rewired it. Yeah. Now I have a toaster oven that runs on 48 volts to 54 volts. And I wanted to test it, so I cooked some hash browns in it earlier tonight. Cool. Thing works great.
Yeah, and these systems are great. Like if the grid goes off, you know what I mean? Most people are, SOL. You know what I mean? Like,
well, that was my thought process, right?
Yeah, it's like something that you could use, when the power grid goes down, and you got nothing to go by. That brings me back to that memory around 2003 when the whole Eastern Seaboard went out. Remember that big blackout we had? Yeah, it was 2003.
Oh, I do. It was huge.
Yeah, I remember that really well. Oh, there you go. There's a toaster oven. Yeah, I got one just like that. Actually, it's in my store.
Yeah, and it just looks like a regular toaster oven, right? See, it's missing. It's missing this element here. I don't know if you could see this back one. And then there's
it's the
two
same
up
one
in here.
Right.
Yeah.
Yeah, I got one.
And it's what I did is basically what's that?
No, it's probably you're hearing my wife in the back.
Oh. So I mean, I could do a demonstration on that really quick. Let's see.
Yeah, sure.
Show you the wattage. You can see it.
Right. What do we got there?
Can you see that?
Yeah, 2.1 watt hours.
That's at max.
So that's pulling just 11 amps. That's all it's pulling.
Yeah, that's
it's
it.
Not that bad.
No, it's not bad at all. And once it gets hot, I'll open it up. I'll show you how red it gets. I mean, I turned it up a little bit because I wanted to see it get red. Otherwise, you know.
Yes, you hear me?
Yeah.
Hey, Mike, how's it going?
That's all good. Go ahead.
Yeah,
but
we hear you.
You can run this, and you can't even see the infrared coming out of these elements. So I turned it up, and my potatoes cooked nice and crispy after now. And the same time as you know what? When this was plugged in, it's about 1,250 watts, I think 1,500 watts coming out of the wall. And it would take about 30 minutes to cook my hash browns. This took about 38. I timed it. So not much of a difference running on 54 volts, like 600 watts.
Yeah, like I'm starting to find out.
I don't know if you could see.
Even with my motors, I noticed greater efficiency if you run at a higher potential. So the higher potential,
the camera will let you see how red that's getting.
The less amount of amperage you need to do the same work.
Yeah, and this is DC though. The reason why I love this so much is because if I turn this down just 100 watts, I can run it off one solar panel, right?
Yeah.
And if I want it cranked up, I just use a solar panel with a battery. But I can go direct from the solar panel right to this thing.
Wow,
let's see if the camera, what my infrared's going to show.
Yeah,
I figured it'd be handy for the prepper community.
Yeah,
yeah, you're starting to see the red, eh?
Yeah, I can see it. Yeah.
See if I could get the. Can you see the temperature on that?
It's kind of blurry on my end.
Yeah, it's kind of hard to see the infrared camera like that because it's a dual screen to screen, right?
Well, if it's cooking stuff, obviously it's working great.
Oh yeah. Yeah, it's cooking stuff. I doubt you can see that. I need a new camera.
Actually,
sucks
that camera's
being broke.
Bad.
You can see it getting red, right? And then up top, there's one in the back you can't see because it's got a curved roof, right? But there's 3 elements in it now, and I'm adding a 4th, which will probably bring my wattage up. But big deal. It'll cook faster.
Oh, Daniel Foster's here. Hi, Daniel. Welcome to the live chat. If you want to join, the link is in the live chat there at the top. If you scroll up, if you want to join us, you're more than welcome to join us. Anthony, you're there too. Yeah, I like that idea. I really like that.
Yeah, I've done videos on it, but I can't edit it until I get my computer back, and that'll be. I already ordered the battery, so I don't even know. Maybe sometime this week.
That's right on. Yeah, so I'm gonna work on these transformers. These transformers actually, you know what, will actually work with the system that you're using right now because they'll ramp up the power right? A step-up transformer. You know, if you can get the power that comes directly off the panel, oscillate, put it through an oscillator, put it up to like 800 kilohertz, and then hook that up to the high voltage, and then from the high voltage module, go to a step-up transformer. You could probably get way more power. Way more power.
I wonder. Because that's kind of what the lines like your transformer lines do.
Yeah, because
pardon me.
The whole idea is getting this high voltage module that I just bought. I just got it in yesterday. If you get it up to a high kilohertz range, you can oscillate a very, very large either step up or step down transformer. What I want to do is I'm going to take, say, the 400,000 volts that it's making in the high voltage module, step that down. The second you step anything down in a step down transformer, your voltage goes down, but your current increases, which a lot of people totally forget about, right? So that's what I want to do with the
Ohm's law.
Yeah, exactly. It's Ohm's law. There's nothing spooky about it at all.
So it's the same principle we use to transfer power. Go ahead.
Yeah, like, this little module, that could be a game changer for the whole system because it requires such little potential to run it, right? So if the Renegade can provide enough voltage to run it, well, now I got 400,000 volts of potential. Now I can do something with it. So now I can step it down from 400,000 volts, say, to 50 or 60 volts. But if I can get 10, 20, 30 amps, that could be a huge game changer for my system.
Heck yeah. You could charge batteries with your system, like large batteries.
Yeah, deep cycle.
To no end.
Yeah, deep cycle batteries. Yeah. So I'm going to build a transformer by hand this week. That's my goal. I have some cores that I can work with. Cores. And,
nice.
See what I can whip up.
So, I'm working on devices right now to add to the system that I've been working on. I'm not going to give an update on the alternator generator or the scooter because I'm doing something really cool with the alternator generator. I want to do like a big, huge thing on. I'm hoping I'll have it done next week. I couldn't get it done this week. I had a whole bunch of other stuff I got going on in the family and blah blah blah.
Yeah,
but yeah, life happens and you're making other plans. That's kind of how it is, right? But I'm hoping to be finished my oven next week. If the wire comes in on Wednesday, I'm building a DC oven.
Yeah, that's awesome.
Like, an oven that goes in your kitchen?
Yep.
A regular oven?
You have to do that. You have to put that on your YouTube channel. You got to show that.
Absolutely. I've got, I got videos for the heaters and I got videos for the toaster oven coming out, but I got to wait for my computer. But when the oven is complete, that's definitely going up as well. So I have like about 6 devices that I've been working on. The 4 are almost complete. Like I got a hot water tank that works on DC.
That's awesome. That's so cool.
Yeah. That's another part of it too. Yeah.
You're like the off the grid guru.
Working on it. Yeah. Well, but I don't want to see. Go ahead.
You know what? That's honestly, that's what I think where everything's eventually going to go. The grid system's eventually going to collapse. The governments won't be able to keep up with that system. The monetary system collapsing. All this bad stuff's happening. So you know what? The only way we'll move forward is by decentralizing power, and then great experience.
I agree.
Great tools like what you're making can make someone's life a lot easier.
Well, here's the thing: that toaster oven, like a toaster oven, is usually anywhere between 1,250 watts and 1,500 watts to cook your food, right? I'm doing it with 600 watts. How much sense does that make? Either way, I've cut the wattage down. You know what I mean? So that's interesting.
The fact that you're not on the grid, you're doing this all free of charge, right?
Yeah.
You know, like it gets so bad. Like our hydro is increased in price. It's like it'll get bad to the point where you have to go watch the bins as you're using the power. It's like, you know, it's good. Eventually, it's going to get that bad, right?
Well, the way that I have it set up now, one panel will do 3 heaters, another panel will do the toaster oven. It's going to take 2 panels to do the actual house oven, and then, you know, so on and so forth. So my heat will be okay at least.
Yeah.
And then all those plans are getting released for free, so everybody can build it. It's so easy.
Yeah, and the best part about it is at nighttime, you're still not screwed. All you need is a stack of batteries. They'll get you through the night when you don't have the sunlight. During the daytime, you got the sun and whatever, you know, or whatever. You know, I've seen guys making these little mini hydro plants, utilizing the stream that they have outside their house, generating their own power. It's pretty cool stuff that some of these guys have done. They'll convert old washing machines into hydro. Little hydro.
For a second there.
So Mike, what have you been up to?
Just trying to promote the flyback loop circuit and get it out there until I end up building it. And then when I finally build it, I'll probably put a video and see what's up from there.
Yeah, I got my
expand on it from there.
Yeah, I got my high voltage module yesterday, so I'll be working with that. Puts out 400,000 volts. It only takes 6 volts DC to run it.
I found a soft.
Go ahead.
It's a transformer.
Yeah. Yeah, go ahead, Joe.
I found a soft iron core for that idea that we talked about last time, Mike, to put the 2 coils on a iron core and then run the flyback system like that. I'm gonna be trying that. I'm just get so much on the go, you know what I mean?
Oh yeah, it's gonna work. Don't worry. Don't worry, she'll work.
Might need a third wrapping around that to collect the
well, I would put an insulator. I would put a good insulator around that core. Like when you get everything done, put a good insulator around it. Yeah. And
the DC pulse will go back and forth. It should create some kind of an AC signal.
Yeah, well, it's a pulse DC signal. So that's why you can run AC appliances with a pulse DC, as long as you got at a good frequency. That's why most of the time I could run AC lights with my my pulse generator, my Renegade device, and run any kind of AC appliance because it's pulsed. It's like an alternating current. It's not true alternating current, but it mimics it. So now another thing.
As long as it's at the right frequency.
Correct.
Yeah, as long as it's at the right frequency, you can do it, eh?
Yeah.
As long as you get over 120 volts.
Yeah. One thing I was I go on Joel's website, Joel Layden's. I've been trying to get him on the show. He's not really responding. I try to reach out to him again this week, no response. But one thing that he did say, when he's got his high voltage module pulsing at 800, I think it's 829 kilohertz, sorry. It's a 400,000 volt module he's got hooked up. What he's doing, he's creating this field around the wire itself, and he calls it the heavy side component.
Oh yeah.
And then he just taps off the one wire with 2 diodes, and then he could extract power off that without killing the dipole. It just keeps running. It's an open circuit. Says the second you close the circuit, you're finished. You're done. Says it has to stay open.
Absolutely.
So Tesla already gave us a hint on how we were doing it. That's why he created the Tesla.
Close the circuit.
Yeah, if you close the circuit, you screw it. you screw it.
It's a pulse circuit. It's going to close and open.
No, if you close the circuit, you're finished. It's done.
Yeah, according to Thomas Beard, you want to
It's a
create the
pulse circuit.
dipole. Yeah.
Is it a pulsing circuit, Mike?
Yeah, it is. High frequency pulsing circuit, but you're only tapping off one wire. And that one wire.
Oh, okay. You mean if you tap off the other negative or whatever?
No,
Okay.
you're only tapping off the one wire.
You mean what you mean to say is if you close the circuit with the load, you mean?
You kill the dipole. It's done. It's finished. So
So you're taking the positive off the dipole and you're just getting your negative somewhere else.
Yeah, earth ground.
Right. That's what I was thinking.
Right. So
it'll go there, huh?
Yes. So what he was doing when he taps off the one wire, he taps it off in a half bridge with two diodes. And then that is your positive negative.
Yeah, he puts a cap between it, doesn't he?
No, yeah, you can add a cap, but the main thing is you got to create a half bridge with two diodes coming off the one wire.
Oh, I found something out that's kind of neat. If you use ceramic capacitors and your system's used to resonating, you'll create just a little bit more power for your system overall.
Oh yeah, yeah. I got a lot of ceramic. I got a 15 kVA.
I guess it makes sense, Mike, that it would go to ground, earth ground, because you're creating a higher potential than the earth.
Right. Yeah. So what you want to do is not tap off the second wire of the circuit. You have to leave it open. It has to stay open.
Right. Because then you would close the circuit with your load.
Right. And you don't want to do that.
I'll give you guys a little tip on the ground. If you guys can create your own ground array or basically run a massive copper coil and bury it, bury it in the ground and use that as your ground, your potential is going to go through the roof. And the reason being is because your voltage is going to want to follow the path of least resistance.
That's right.
You're essentially going to be tapping the flow of the earth in a way.
Yeah, exactly, and that's what Tesla talks about. Nobody's caught on to it.
Which point has the ground or the positive of the flyback?
Sorry, say that again.
Because the earth ground has, lower potential than the positive of your flyback, which is up in the hundreds of volts.
Right.
So as long as your earth ground is less than hundreds of volts, then your positive flyback will go to the earth ground because it's a lesser potential.
That's right. Yeah.
But you can't have the earth ground being a greater potential than your positive flyback. You're only the positive now, not the negative.
You're hitting on a secret, Mike. Listen, if you can create an oscillation between your positive and the negative in the ground, your negative potential is going to go like crazy. It'll go to a positive, so it's going to want to get the hell out of there, and it's going to shoot back to you.
Well, that's the other direction, right? That's going the other way, though, right?
Yeah, you're going to create an oscillation
from negative to positive,
right? So Don Smith,
and you're going to tap the earth.
I get what you're saying there, Gerald, but I'm talking positive to negative at the moment.
Yeah, see, Don Smith.
Of course, from the earth back up to your circuit is another story.
Yeah, Don Smith
That's the other direction.
Exactly.
Yeah, you're right.
Don Smith actually put a diode from earth ground facing towards the circuit, not to earth ground. He was at it in reverse because he knew if he had it in the right oscillation, just like Gerald was saying, you're going to start pumping current from the ground. And that's why he had a flyback diode at earth ground facing towards the circuit. And when I was listening to him, I'm going, what the hell is he talking about? And now I understand exactly what he's talking about. You get in the proper resonance.
It's complicated.
Yeah, it is complicated. I didn't get it at first at all, right over my head. But when I went back and watched his video, if you get it in the right resonant frequency between the one wire and ground potential, you'll start pumping amps from the ground. And that's where you put the flyback diode facing towards
You'll pump the negative current. The negative will flow, right? The current flowing from the negative to the positive is what will be coming from the earth ground.
Yeah, exactly.
But not the current flowing from the positive to the negative. That's our current. That's our positive flyback.
That's right.
Well, not the negative flyback. Just the positive flyback.
But it'll push against.
Right.
You're right, but it's going to push against the negative, and by them fighting, it's going to create current.
Yeah, you get an oscillation within those two.
Does that make sense? You know what I mean?
Yeah.
The two potentials, as long as they've got a differential, they're going to be attracted to each other.
Yeah.
Yeah. And
so I guess your positive flyback, like assuming it's 1,000 volts, you know, positive.
Yeah, it's really funny how it reacts. You have to experiment. Like a lot of people, the really good house ground used to be actually the water pipe of the house. A lot of people used to use that back in the day as a good earth grounding system. So yeah, I want to do some experiments this summer in an area where I could actually put a ground rod in the ground. So I want to see the potential difference.
Absolutely.
See if I had like a cottage.
Or find yourself an old well.
Yeah, that's the thing. Well, all the cities cut off the well access for us now. We used to have a water spring nearby. They cut it off. It won't allow us to get spring water anymore from the ground. What the hell is that? It's like they don't want us to have clean water.
Right.
They'd rather get tapped.
You know what you could?
Go ahead, Joe.
Find yourself an old concrete building that's broken up and tap the rebar that's sticking out if you can find some.
Right.
That'd be an awesome ground.
Yeah. Yeah, there's so many things I want to experiment. It's not enough hours in the day, right? But yeah, I'm going to be.
All right. So what's going to happen when you got a positive potential coming off your positive flyback of that side of the coil
for this summer, so that I can go on the road and experiment.
Yeah, I got a lot of good areas where I can go into higher elevation stuff. So yeah, I definitely want to see that. So, see if I can get better results in higher elevation.
You guys keep spinning.
So what I'm thinking is when you got that positive flyback off the positive, that one end of the wire on the coil, and then you got your load between that and the earth ground, that's going to be a higher potential than the earth. Right. So whatever negative energy is in the earth or negative potential, it's going to go to that positive from the earth, and whatever positive potential is on that one end of the coil, on the positive end of the flyback, is going to go to the negative potential, the lesser potential into the earth. So you're creating a channel between the earth and your positive flyback on that one end of the coil.
Yeah. So that's where you're going to tap right off of there.
That makes sense. I didn't get last Friday. I wasn't catching you on this thing, this killing the dipole and how you do that and all that.
Yeah.
So you're not using common ground. You're using earth ground.
Yeah, you have to use an earth ground. See, the second you close the loop, right? Now you're drawing a current. It's a closed loop system. So now you're taking off that.
Yeah, from you're drawing from your source, your own source, your battery or whatever.
Yeah, exactly. So if you prevent doing that by the way Tesla was doing it with this Tesla coil, and then using just basically the missing component
bits
ground, right? He just used the earth ground. So now he's got this free flowing potential, and he got that high voltage line absorbing all the background energy or the heavy side component. Now you're getting extra energy into the system that you didn't have to pay for. It's just coming in.
Well, everybody keeps mentioning this heavy side component. You know, what is that component? Can anybody round that off? What is this component?
It has to do with the field that's created around the wire. It's an electrostatic potential. An electrostatic potential.
The magnetic field?
It creates a magnet. Well, the static potential is a magnetic field, and that will pull in any energy that's in the space around it. It starts sucking it
so
in.
The heavy side component is the magnetic field around the wire.
Well,
when the electric current.
Well, the static energy that's created around the wire starts pulling in that radiant energy from around the space. So
it's not the magnetic field per se. It's the static field.
Correct. Right. Exactly.
It's the byproduct of the magnetic field.
That's
or
right.
Whatever.
So it's pulling in the dielectric from the dielectric medium to the static field, and then because the static field is surrounding the wire, anything that static field draws in is now getting absorbed by the wire and now running on the outside of the wire, because energy doesn't flow in a wire, it flows on the outside of the wire in a corkscrew like this as it's going down the wire.
Sounds a lot like that energy that William Reich discovered,
like
orgone or whatever.
Well, that's what it is. Orgone energy is a byproduct of the static potential or the heavy side component. It's one and the same. Yeah. Yeah, and that's what Joel Ladens was talking about in a lot of his videos. I went back and listened to him over and over again. He's right, because it's drawing in this extra energy, right? So I'm pretty excited about this high voltage module I got. It'll be very interesting to see what happens when I hook it up to the Renegade. So as far as I know, I only need about 3 to 6 volts going into the high voltage module, and then that's going to produce about 400,000 volts. So now the trick is making the proper step down transformer. So when you step down high voltage to a lower voltage, it drops the voltage down and the amps go up. So at 400,000 volts, you have maybe microamps of current, while when you step it down now, you might have several amps. I can't really.
So you're anticipating during the conversion some gain going on.
Yeah. I'll go down in the voltage, but I'll increase
because you're not killing the dipole.
That's right. Yeah, I'll be tapping
when you're doing it. You're right.
Yeah.
Okay, I see.
Yeah, I'll be doing.
I see where you're going.
Yeah, I'll be doing it off the one wire. So just give me 1 second here, guys. Sorry about that, guys. So, Gerald, any other thing you want to touch on? Anything else?
No, it's been kind of a slow week for me.
Yeah, I've just been this week. I've been doing a lot of 3D printing, just ordering some parts I need, and just kind of gathering my ideas, doing a little bit of research on some stuff, heavy side component, all that kind of stuff, transformers, step down transformers. That's what I've been really working on. So now I got to put some of those ideas down, show practical application that we can start building. I got quite a few little small transformer cores. I got toroid ones. I got the standard ones, big, small. I got quite a few different sizes I could toy around with, and it's kind of funny how some of the stuff that I want to do now is kind of go back to the Don Smith stuff. with the step down transformers and stuff. Or step
That's
up
because
or
Don
step
had
down.
it right.
He did, yeah. I think he was very cryptic on how he was doing things, right? So
Yeah, he kind of had to be. He was attacked, and like if you read his what is it, his book or his notes? I can't remember. Talks about the Russians that attacked him, or was that no? That wasn't Don Smith. That
no. That's more. That was T. Henry Moray.
Yeah, sorry, I'm getting them mixed up.
Yeah, that was T. Henry Moray. He was almost abducted by 2 Russian agents. And, that was in New York City when he was doing a conference. They tried to abduct him. So these are actually real stories. But no, Don Smith, he worked in the oil and gas industry, and that's where he originally started. He was like a geologist. He had to find the oil, and his story all in its own was pretty fascinating. How he went from working for the oil boys to free energy. So it's a pretty interesting story he had. I think personally, a lot of his devices actually made him sick later down the road. He started getting a lot of, he was having strokes, like micro strokes. Eventually, that's what killed him. Yeah.
And that was from his devices?
I think, yeah, some of the stuff with the spark gaps that he was playing with, he might have been playing with stuff that might have been a little bit dangerous for exposure. So, it could have been X-rays, or it could be radioactive type stuff that he might have been hitting.
Yeah, I get that. He was playing with that stuff, wasn't he?
Oh yeah, well, he was playing with the spark gap all the time, right? So, you can play with the spark gap so much, but you'll get to the point where you're getting into super high potentials, and the super high potentials, you really don't know what's getting emitted from it. That's why I kind of backed off his stuff for a while, because I really want to be sure that I'm not getting exposed to too much radiation, or X-rays, like Fleischmann and Pons, when they were running their cold fusion reactor there back in the early 90s. They're emitting quite a bit of X-rays. So
yeah, I know all the work that I've done with all these electromagnetics. Whoo, kind of worries me a little. Might have shortened some years on that.
you might be the chicken in the oven. That's kind of funny, but yeah, that's a it's a very real problem, right? Even like the old tube TVs. Remember, Gerald, the old tube TVs? They had some components in there that were like radioactive. Like, a lot of people don't realize this stuff. Like some of the old high voltage tubes, and some of the old power tubes, they would get this like brownish tinge on the inside of the tube, and it would short out. Well,
yeah,
all the TV repairmen that had to replace those tubes, they're all getting cancer. Well, it turns out that stuff that was inside those tubes was radioactive.
Oh, that's not good.
No, but that's back in the 60s and
still
70s.
Have quite a few of
right?
Those TVs.
Yeah, I remember we had an old Viking. The thing was like a piece of furniture. That's how it looked like. It was all made of wood. Then it had these giant transformers in there, and vacuum tubes, and the tube itself.
You keep spinning.
Yeah, like unreal. So yeah, those old TVs were something else. They were like if I could get my hands on one of those old TVs today, like some of the components in there, my God, like diodes and the tubes, and even the TV tube itself, with the electron gun that was in those TVs. It's just unreal.
Well, I have a 1986 32-inch Sony Trinitron.
Yeah.
And I have a 1984 It's like a 26-inch. You know, I got a bunch of those old TVs. I think the oldest I got is a 74 Electro Home.
Wow.
So I don't know if those have radioactivity in them or not, but
oh, they could.
probably.
You know, yeah, they probably do. You know, going back 50 years ago, yeah. I was born in 73, and
Yeah.
my parents already had that Viking TV. That TV was made, I think, around 69, maybe.
Oh, I remember the Vikings.
Yeah, the big one. It looked like a piece of furniture.
Yeah, we blew a few of those up with sledgehammers, man.
They were big. They were big and they were heavy.
They were.
They were like 150, 200-pound TVs.
Oh, at
Yeah.
least 200 pounds because all the wooden
yeah.
cabinet that was built around it was insane.
Yeah. Yeah, it was huge. It was a piece of furniture.
I remember those.
You could eat your dinner on the damn thing.
Yep.
It's like, yeah, they were.
Yep.
And you could jump on top of those
It usually
things,
took like 2 to 4 guys to move it into your home.
Oh yeah, they were heavy.
Oh yeah, for sure.
And the one we had,
Yeah, you could dance on one of those things. They were so
that
heavy.
one there, if I'm not mistaken, was a color. If my memory is correct, it was one of the first color TVs out. And then my father at that time, we had a giant aerial on the top of the house because there wasn't cable back in the 70s. It didn't exist.
No,
it wasn't out yet.
We had like 4 channels.
Yeah, 4 or 6 channels. All the stuff we had, we were getting all the transmission directly from the CN Tower. That was the TV transmitter. That was the CN Tower. That was part of the reason why they made the right. So
you get 2, 6, you get 10, which was French. You get 12. Sometimes you get 13.
Remember
those days.
Remember the old Gerald box that came out, you know, the push button box, so you could change your channels without going up to the TV.
I still have one. I still have one sitting in the back room, man. I'm telling you.
Awesome. I have so many good memories of that thing. That was like the shit.
That's awesome.
That was like the best thing ever when that thing came out.
Did you know that the original? Here's something I bet you. I don't know if you knew. Did you know that the original Nintendos had an RF out on it, and they were actually set up to make you a little small TV station?
Really, eh? That's cool. Yeah, I do.
Yeah, you can run you could do video on your TV downstairs and project it upstairs through that box. Yeah, it was really neat. You could set it up through your cable.
Right. Because it hooked up to the aerial.
As soon as they found out that you could boost them, then they took they took those right out of the machines.
No, what was really cool too is remember the old Telestar game that came out for probably about 1978. It had 2 knobs and it played like 4 games like Pong and had tennis on it. It was a big white box.
Yeah.
Remember, it was kind of curvy, round, and it had 2 knobs.
Pong was a good game.
Yeah, it was called Telestar. Well,
that was the one before ColecoVision, right?
That's
Coleco, right?
Yeah, it was before ColecoVision. Yeah. My brother actually is restoring all the old Commodore computers right now. He restored a Commodore 64. He just restored a Commodore 64. He's got some old tube TVs. He's like restoring all the stuff from the early 80s that we had when we were kids. And he had to get new BIOS chips because all the original chips were bad, right? So they made new aftermarket that you can install into these and actually get these old computers running again. So yeah, he's actually, my brother's electronics engineering technologist. So in his spare time, that's what he does, restore all these old computers. So it's pretty cool what he's done.
That's awesome.
Yeah. So he makes amplifiers, restores these old computers and all this stuff. So he's a tech head too, right? So guys, I'm just gonna you can talk with Mike. I'm just going to go for a quick smoke. I'll be right back. You're up for the challenge, Mikey?
Yeah. Your computer keeps breaking up, though.
Is it? Yeah, I'm having trouble tonight. We got a storm coming in. Freaking lot of rain coming in, so it doesn't surprise me. But I'll be back. Give me 5 minutes.
That could be why. Yep.
Hey, Gerald. You know, if you want to mess with that circuit, you could use double pull,
Hey,
double
Mike,
throw relay.
how are you?
How you doing, man?
Oh, double pull, double throw relay. Hey, I'll come out and I'll talk to you in a second. I'm on live. Sorry, bro. Yeah, sorry, somebody came in the room. Yeah, double pull, double throw relay. Wow. Never thought of that.
I'm
That
not
might
sure,
work.
but you can probably use one relay to
Sorry,
do.
I'm just going over that in my head.
Yeah. Yeah, I know, it's a little bit. The double pole, meaning the positive and the negative
Yeah, to
pole
do
being
the
switched
switching.
together.
I know what you mean by that.
So yeah, it's like two switches in one.
That's an interesting thought.
You don't have to use
To flip them back and forth
transistors.
really quick.
Right, and because there's two switches going like that, I'm not sure, but I believe there's two contacts on each side that it touches, the two conductors. So you might be able to use one double pole, double throw relay to do all four poles on the two batteries.
Oh, I know what
I don't
you
know.
mean.
I haven't gotten around to it yet. But
I don't know. I wonder if you could. That's interesting thought.
yeah, you got to look closer at the
You got some
double pole,
interesting
double throw
ideas,
relay
Mike.
first. Yeah, if not, you can always use two of those
I definitely
relays.
have to look at that. There's a company
worst,
that
you know, you
sells a
just use two of
digital
them.
one for $50. It actually goes high frequency.
Double pole, double throw, huh?
Yeah.
They have. I didn't know they had digital double pole, double throws. That's crazy.
Yeah,
I thought
they're
they were
kind
just
of hard
analog.
to find. I had to do some digging, but there's a most time, for the most part, they are. But there's one company that does it. They do it for like machinery.
Yeah. They're gonna keep building all kinds of relays and switches.
But yeah, I want to try that for sure. That actually. Go ahead.
I'm just going crazy without having a lab. I'm getting to that point where I need my table back.
Yeah,
I don't have a single pulse motor running or nothing. Say again?
Yeah, you were heavy into pulse motors for a while, weren't you?
Yeah, I had a lab, but
hey,
I had to disassemble it.
Yeah,
I figured out what I was trying to figure out,
totally.
and then it was just the table was so messy. There was no fixing it. I had to just clean it all up, throw everything in a box, and start over. That's how messy it was.
Yeah, I hear that. I'm working on a few different projects. I'm almost getting to that point. That's why I'm finishing them up, putting them away. You got to get everything done.
It's like you need a table for
doing
each.
The same and just letting it all pile up.
You need a dedicated table for each project. You know.
Yes.
That way,
you actually
you don't have to. You don't have to, search around for stuff anymore. You just keep all those parts on that one table for that one project. And don't put anything else on that table. That's where I'm going to go next.
My last house was perfect for that. It was huge. This house is small, though. I don't have that opportunity.
Like a 4x4 table.
But
2 of them.
Yeah, that would work. I could use like the amount of stuff that I got going on right now. I need a whole other basement.
Yeah, that's why, just use your lab to make a mess on one project to get that thing out of your hair, just that lab is for that one project. And once you're done figuring out what you're doing, then, reset the lab for the next project,
Yeah,
I can't think of any other way to do it. It just gets so hairy when you start mixing projects together in the same lab.
it does get hairy. It does. That's why I'm finally finishing up on things and sticking them aside or shelving them for now until spring to like do the tests, right? All
Yeah,
these
you're
different
you're still
devices that I'm
experimenting
building.
or doing R&D, right? Your stuff. So
Yeah, for
when the
the
R&D,
most part, there's another 5 devices that I want to build, and then I'll.
I mean, if I
What's
can
that?
give you some advice on continuing your builds, if usually the lab is only suitable for one, build. So the other builds, keep working on them, but on paper, and not in the lab, but on paper until you have the time and space to put that next build in the lab,
Sorry about
and
that, guys. I'm back.
Oh yeah,
there's
I
not,
get
no
that.
reason why you
I
can't
totally
keep
get
drawing
that.
stuff down, right? Drawing it out. And
Yeah.
that way you can forget about it and move on once you have it drawn down,
My
Yeah, I try to
creative brain
focus on.
doesn't allow it to go that way, though. Go ahead, Mike.
Yeah, I
Well, you
like
won't
to.
really forget about it, but you know what I mean. You clear up some space up there,
Yeah, no, I do.
Usually, I don't
Yeah,
like
I
to have
do.
more than 2 projects going at the same time because you have to keep your focus on the project that you're working on, and then move on to the
It's a
next one
rabbit
down
hole.
the road. So maximum I work on is 2 projects at any given time. If you go any more than that, you're just getting in over your head. And you got too much information going through your head. You get you kind of
It's a rabbit
I
hole.
had
You get
8.
stuck in the rabbit hole.
8
It
projects.
is. I had 8 going at one point because I'd run into a roadblock on one and be missing a part, so I'd have to order it. So I'd work on something else. Finally, I'm catching up now. So I have 4 done, and I have another 4 to complete. Then I should be okay.
Yeah, little by little, right? Look how long I've been working on
But
it.
I'm getting called upstairs here, so I'm gonna have to bail on you guys.
That's all right. That's cool. I'm glad you came on.
Can you hear me? Because it keeps spinning.
Yeah, no, I hear you. You're okay.
Yeah, did you hear that?
Yeah, yeah, yeah. I can hear you.
Yeah, yeah. No, I
Yeah.
apologize to the audience and to both of you guys. Just I
No,
got
that's
some
fine,
stuff
man.
going on here.
Yeah, that's cool. Yeah, if anything cool,
Yeah. So
shoot me an email or whatever.
next Friday, are you?
Yeah, next Friday. Yeah, definitely. Every Friday night, same place, same time.
So next Friday, I'll try and do an update again and show the next
Yeah,
projects that I'm working on. Maybe do a demonstration of this heater. I just couldn't get on
yeah. I want
camera
to
tonight.
be. I want to get something done for next week too. I want to see if I can pull together this transformer and see if I could get some results out of it. Definitely for sure. Mikey, you look like you're tired.
Yeah, I'm always
Yeah,
tired.
that sounds good. I look forward to seeing it.
Yeah. Yeah. Thanks, Gerald. We'll let you go. Thanks again.
See you, Gerald.
Yeah, definitely.
We'll chat soon.
See you, Mike. See you, Mike. It's like
Yeah.
Mike and Mike.
Mike and Mike.
Right on, guys. You guys have a
Okay.
good week, and we'll see you next Friday.
Yeah, cool. Yeah, so yeah, that's gonna be my big thing. I wanted to see if I can show something here for a second. Just bear with me.
I didn't catch you with that killing the dipole thing till just tonight, really.
Yeah, it's hard. You know what? Some stuff is hard to wrap your head around.
When you said you can't close the circuit, that's when I started.
Right.
What do you mean
Yeah.
you can't close the circuit?
Yeah, it's got to stay open.
Then I realized you must mean you can't close the circuit with the load. You know, so hey, you know that means you can take the negative flyback alone as well as you're taking the positive flyback.
Well, yeah, you take the negative flyback right from Earth ground. And that's what Tesla.
No, well, the negative flyback is coming off the coil. The coil
Yeah.
also has a positive flyback. You're
Yeah.
only using one or the other, right?
Yeah. So
With your load.
you're still completing the circuit by Earth ground. I think that's the
And that means you must be using the positive flyback on the coil and then the
Yeah.
earth ground.
Yeah.
And the load in the middle.
Yeah, you grab the load from the middle in between the earth ground and the one wire tap off. Yeah.
That's better than doing it from your positive flyback to your negative
Yeah.
flyback
Yeah,
with
what
your load in the
Tesla
middle.
was doing in his diagram, he actually had like a spark gap discharge in between that circuit. You know, he didn't have a switching device like we have now. So he was using like a rotary spark gap, and then from there, he dumped that right into a huge capacitor bank. And then from there, he could do what he wanted with it.
Yeah, but he was using the positive of that flyback, and then going through the load, and then the negative was the ground.
Right.
What did he do with the negative flyback? He kept it alone, left it alone, and let the positive flyback
Yeah,
channel to it,
like Don Smith, he actually had
as well as the earth ground, I guess.
Don Smith actually had a diode in reverse. So where you think the diode would be directed towards earth ground, he actually had it in reverse. So if there was any charge or whatever, electrons.
He had the arrow pointing up away from the ground?
Yep.
Well, that would, yeah, wow, that's interesting.
Yeah, that's what confused me too.
That would only allow positive energy out of the ground, not negative.
Yeah,
And
a lot of this stuff is very misleading.
that kind of makes sense because it's still two positive. It's still two positive potentials. One greater positive, one lesser positive.
Right. So one, it will be the more dominance, obviously, can be positive.
The greater positive is going to flow to the lesser positive.
Right. That's right. Exactly. One will be
So if
more
he did have his diode reversed and there was a greater positive coming from the earth, it would flow to his circuit from the earth as a positive.
Right. From the ground. Yeah. Yeah, he was very cryptic in a lot of his stuff. Like when you seen his conferences, it was like he was like reading from a script all the time.
Talking about Tesla or Don Smith?
No, Don Smith. So when he did his conferences, if you watched all his conferences, they sounded exactly the same thing. It was like he was reading from a script all the time.
Yeah, I mean, he never talked about transistors with his circuit, so I don't.
No, he didn't really talk too much about this. A lot of the stuff he did didn't really involve a lot of transistor work. It was all diodes and dumping, the field into, transformer or into capacitor bank. Yeah.
So what was he switching with? Capacitor dumps?
Well, he was starting a circuit with a high voltage neon transformer.
Oh, that'll be your oscillation then.
Right. And he was controlling that with the rheostat from a small inverter.
So it's an AC device.
Mm-hmm. Yeah. So he would control that with a rheostat to an inverter, go to a 6 or 10
Still though, the device, the Don Smith's device sounds like it's switching, even though it's AC device.
well,
You can,
his switching was kind of based on disruptive discharge. So he wouldn't change it to 60 hertz until he got it to just before the transformer at the other end. And he would use a set of diodes and resistors to actually get it in phase, get it at the 60 hertz.
get the AC in phase?
Yeah, to get the AC in phase. So
Well, the diode would just rectify the AC. It wouldn't.
Yeah, you rectify it, and then when you put it through some resistors, and that would change the frequency going into the transformer. So by the time it came out the other end of the transformer, he had it set at 60 hertz. So,
Do you have this circuit from him that you were looking at?
see, all the circuit diagrams that he had online were very, very inaccurately drawn.
Yeah, I noticed that.
But you know, the whole circuit itself is really not that hard to understand. Very simple. And there
So he's stepping up the voltage with an oscillating transformer, dumping that into capacitors.
Yeah, capacitors. He had, you know, he had a whole stack of these capacitors. I don't know how many.
And those would discharge to the spark gap.
Yeah, well, that was at the beginning of the system. At the end, he would dump all that disruptive discharge into these high voltage capacitors. Well, he would rectify it first and then put it into the capacitors. Then from there, it would go through these series of resistors that would get it into a 60 hertz oscillation. And there, that's when it would enter the transformer. And out the other end would be your load. And he was doing that all in a solid state. So he had to do a lot of tinkering.
So wait a minute, the diode he was using was rectifying, but it was still pulse DC. It wasn't constant.
Right, exactly. It was still pulsing.
That's how he was able to
he had to sculpt that power with the resistors to get it to
get it in phase, because it was still pulse DC. He was able to get it in phase. Okay.
Yeah, he did it all in solid state, and the way he was doing it for somebody who's a novice would be very, very difficult to figure out how to get it to a 60 hertz oscillation, because he had it oscillating at 60 hertz before it went to the transformer.
So he would rectify the AC to a pulse DC.
Right.
And then he would use resistors to find the 60 hertz from the pulse DC.
Exactly.
I could see that. I could see that. Yeah.
Yeah.
That's interesting. That's like that's a jerry rig, no?
I guess you could. Yeah, I guess you could.
I mean, if you ask me, that's a jerry rig right there. Maybe it's a great way of doing things, but
it was a solid state version of, you know, the way you could do it a lot easier now with electronics.
It's like an improv. That's like an improv right there.
Yeah.
Improvisation.
But he got it to work, and it did work, and a lot of people were able to replicate what he did. Now, mind you, there are many different variations of this system he had. But
where did you read or hear about him rectifying the pulse DC and then sending it through resistors to make the phase and all that? Where did you hear that?
I've seen it all in his YouTube videos. He had his conferences and interviews. He talks about that and shows it on the screen. But
he specifically says the diodes and all that.
Yeah.
I got to pay more attention to that next time.
Yeah, one of his early videos. You got to watch one of the early videos before you start having the strokes, so you're able to understand what he was actually talking about. It's one of the early ones, probably about 1995, 1996 time frame. Around 2000, that's when he started getting the strokes, and then he eventually passed away in 2009 or 2010. Sorry.
You know, by adding resistors to the high voltage DC pulses, you are dropping the voltage and increasing the current.
That's right. That's part of the reason why he was doing that
So that's how he was stepping down the voltage and
stepping
creating
down
his
the
current
voltage and creating his current right
without a transformer.
there. Yeah.
I've seen devices. I mean, I've replicated devices that can step down voltage that have no coils, just using capacitors.
Yeah, basically running it off of reactance. Yeah.
I mean, that's incredible.
Yeah, that's where you get.
I've built this before, and it works. And you could drop voltage with no coil, no step down transformer, just capacitors and a rectifier.
That's right, and you will get amps.
No, you still get amps. You need to use another
No,
capacitor.
it'll increase your amps because see when you put it in, say,
Well, you use a separate capacitor in a series to the parallel with the other capacitors to the series capacitor from your hot side is handling the amps. So depending on how much microfarads are in that capacitor, it determines how many amps you're going to get out.
That's right.
And that will also increase your volts at the same time.
Yeah. That's the whole point of doing it like that.
Sorry.
Because you say here, see, he was using neon side transformers. They're putting out 5 kVA, 10 kVA. Well, you can't dump that potential into a light bulb. You're going to blow the crap out of it, right?
Well, it's funny because capacitors have resistance, and he used resistors to do the same thing.
Create the right frequency. He had
that these capacitors do with that circuit.
He had to do so much tinkering to find the right resistor combination to get that. Lot of resistance. Yeah.
And by adding resistance to that part of the circuit,
slows the waveform down, gets it down. Instead of in the kilohertz.
Would it not heat up at that part?
Oh yeah, you're gonna get heat too. Yeah. That's where the amps is. When you start getting the heat like that, that's where the amps are, right?
Right.
Because you're starting to bottleneck a huge potential into a small potential, but now you got all this current behind it. The current's got to go somewhere. So that'd be great for like induction heaters and stuff like that. Yeah.
You know what I think's going on when you see that heat? It's like you're pushing a bunch of water from a bigger tube into a smaller tube.
Yeah, you're bottlenecking it.
And that's why you have the heat,
Yeah. But you got to balance it out to the point where the system's not going to fry itself.
What I did to get rid of the heat on this one device, it's the poor man's sulfator device. It drops the voltage without the transformer, but the capacitor that was handling the amps was getting. I'm sorry, the capacitors plural that was handling the voltage drop.
Yeah.
They were. I only used one capacitor, and it was overheating.
Yeah.
And it ended up blowing. So I then added more capacitors with lower ratings in parallel to disperse the heat amongst more mass of capacitor mass.
Energy.
And now it doesn't overheat.
Yeah.
Or the heat is the same amount of heat is there, but it's split up amongst more capacitors.
Yeah, you're splitting it up. Yeah.
And now you don't have a failure,
Yeah, you're splitting it up between multiple load points.
And that's when you said resistors plural. It reminded me of that. That's why he had more than one resistor to spread out the heat or the bottlenecking.
Yeah. See, you want to limit the amount of heat too, because that's hysteresis. So that's actually when stuff starts heating up like that. That means destruction of the current flow. So the idea is to get that right balance.
Where created more channels for the current to get out.
Yeah, get the right balance there so you're not heating up. So yeah, he, like I said, he did a huge amount of tinkering to get it right. What he was doing was not easy.
Do you remember the resistor values offhand? Or?
No, I don't. It's been a while since I've been tinkering with that stuff.
Yeah, that's an interesting device, but it puts out like, I don't know, it gives you give it 50 watts, it puts out 200 or something like that, right?
Yeah, well, he was putting a lot less than that. He was putting out only about, I think, 6 watts. He was getting out, well, his early devices were 500 to 1,000 watts, and then his later
From
devices
6 watts.
from 6 watts, yeah.
Mm.
And then he was getting into the multi kilowatts, like 40, 50 kilowatts. Yeah, 100 kilowatts. So they were very, all capacitors. It's all capacitive reactants. He used a lot of reactants in his devices.
To get up in the higher kilowatts, did he have to add more coils or just more capacitors?
More capacitors. He was running his
Just he
system
kept the same coil and he just increased the capacitors.
because at the back end of the system, he was running a high frequency with a lot of capacitors. So therefore, he was getting a lot of inductive reactance in the coil and in the capacitor bank, and then dumping it to the load. And then from there, he would set up his resistors, get in the right waveform, and then dump it into the transformer, and then modulate the power that way, right? But like I said, he's really cryptic. He was one of those funny inventors where he would show us stuff, but he wouldn't show too much. You know what I mean? He was like he had this thing like didn't want to really give away his baby kind of thing. So he was very, he would say stuff, but he was saying in a way that every time you heard him talk, it sounded like the same shtick. You know what I mean? And it was like, yeah, it was like that, exactly like that. It's every
Well, it's a basic system. I'm sure he got it figured out in his head. Just like Bedini had his basic system figured out in his head. So and the way they're going to explain it is pretty much standard from there on out.
Yeah, it's understandable to them, but for somebody
Right.
else, sometimes it's like a puzzle you got to figure out because it's not that.
I mean, I could sit there and say double pull, double throw 1,000 times, and the other guy on the other end listening is me in the past, not getting it.
Yeah, exactly, and it's perfectly clear to you what it's doing. Yeah. So yeah, it's one of those devices that takes a while to develop. So kind of part of what he's doing now is going to kind of go into my system. So I'll be kind of revisiting some of this stuff again because I'm going to be using that high voltage transformer module.
What I remember him talking about a lot is the upping the voltage and then bringing it back down kind of thing.
Bringing it down, and that's what Tesla did. Tesla, if you saw all his devices, they were in the hundreds of thousands of volts. And then from there, he would step it down because
bring it down, and that's
because it takes less current to create a high voltage. Okay, so as soon as you get that potential really, really high, now you have the potential to do anything with it. So by Ohm's law, when you drop the voltage down, your current increases. That's why this little high voltage module is 400,000 volts, but the current's only in the millivolts.
Your current increases, and so does your resistance.
Right. So when you're dropping that voltage down from a high voltage potential down to a lower potential, okay, you're dropping your voltage down, okay, which you want to do, but at the same time, now you're gaining current. That's power. That's the horsepower you need to drive.
So your plan is to take the one wire system, don't break the dipole, send a few volts through your transformer with the one wire system,
right,
and get yourself a free source of voltage, stepping up voltage for free, basically.
Yeah,
if you can,
with that module, yeah, because I know it takes 3 to 6 volts to run it. So
because you're not killing the dipole, you're pretty much.
So I'm going to be basically triggering it like I would a MOSFET, but I'm using the pulse motor instead to do it. Okay, so now I don't have to worry about that little module overheating because I'm pulsing the power going into it, and now I'm creating these huge spikes of potential. And now I can take those huge spikes of potential and put it into a step-down transformer. So if I could get it down to say 20 volts, if I could get 10, 20 amps of current.
Oh, so you're using the step down. You're using transformer to step it down. Okay.
Right. I'm going up first and then I'm stepping it down.
Well, you're going up with the flyback. The flyback is your up.
That transformer, yeah. That transformer I bought, the high voltage one. So I'm going to step it up with that one. And then the discharge coming off that, I'm going to put into a step down transformer. Now that
Another transformer.
Right. It's going to be 2 transformers. So the second one is a step down. So now I'm taking that 400,000 volts I just created. I'm going to step it down in the second transformer. And while I'm stepping down the voltage, I'm also increasing the current.
Is it 400,000 volts? Is that the one wire system?
No. Hold on 1 sec. I'll get it for you. I'll show you. Hold on.
That's one of those zapper things.
Yeah, so it's one of these guys
Right.
here. So you put 3 to 6 volts in the 2 wires here, and then this is your discharge. We'll go to 400,000 volts at about 20.
And you're going to power that with the
right.
with the
So
renegade.
this from here is going to go to the step down transformer. So it'll probably be about 300 to 500 turns. This will go into, and then on the other side of that, go to 2 wires that are probably going to be a.
Allow me to try to map out what you're doing here. You're taking a rectifier, rectifying 3 volts out of the 1 wire system into a capacitor to power that thing.
Yeah.
And then it's going to create your high voltage.
Right.
That you're then going to rectify again?
No, it's going to be pulsed into the second transformer, which is the step down. And then after
which is
right.
Which is two of those things.
No, one of these guys and 1 step down transformer.
Another type of transformer. Okay.
Right, the step down. This one's a step up, and then after the step up, it's going to go to the step down. So it's going to go from 400,000 volts into the second transformer's primary windings, which is probably going to be about 500 windings of small gauge wire. Okay. And then on the other side of that transformer is going to go to 2 wires that are probably about 8 gauge. And that's the potential that I grab because it's still pulsing.
With a few turns on it.
Right. And then I have to put that power now into a rectifier.
That would be the primary.
Yeah. No, secondary. That's the secondary.
I thought the secondary was the one with more turns.
No, less. On a step down, it's reversed.
Oh, so, you're right. On a step down, right?
Yeah.
So that's how they do it on a step down. Okay.
Yeah. Yeah. So the primary on a step down is like 500 to 1,000 windings, and then on the other side, the secondary, where it's stepping down, would only be about 2 to 3 wires wrapped around. You'd have to experiment how many windings you need. The more you put on it, the higher the voltage, but the amperage
it can handle.
Right. Yeah. Now those.
Well, even if you have, let's say you're pumping a 1,000 watts at it, and your primary on your step down can only handle 900 watts, it'll still capture the 900.
Yeah.
And if your primary on the step down can handle 1,100 volts, it will capture only the 1,000 that you're giving it.
Right.
And then step it down.
Shoot.
And of course, stepping down your voltage, your amps goes up right there.
Right.
And it's true, you don't need a lot of amps to make the high voltage.
Just bear with me here for a second.
But if you're not tied into earth ground somehow, I don't see maybe pulling it out of the atmosphere as well. I guess you could.
Well, you're doing that essentially with the high voltage one, right?
Right, but then why do you need the earth ground then?
Which
you can get it out of the atmosphere. You can get it out of the radiant, out of the out of the air.
Well, that's a
environment.
different system. I'm talking about the one that I'm working on with the motor. That's if you're doing the one wire system like the one Joe Ladens was working with. Yeah. So what he's doing is one wire tap off that one potential wire, putting the two, or basically what he call a half bridge. So only two diodes. One of them is going to receive the power, but the other one's going to get the negative. And then he says you can tap off that wire as many times as you want and dump it into a capacitor bank array. Just keep dumping it into that. That way you're, his perfect example was using a Tesla coil. So off the ball off the top, you would have one wire coming off, and that's the wire you tap off.
And you leave the negative of the flyback alone.
Yeah, you just leave it alone.
You couldn't tie it to earth, ground also? It wouldn't work, huh? Wouldn't help. Probably not help.
Probably wouldn't make a difference. I think he just left it. Yeah.
It is a negative, I guess. Have you seen the Carlos Benitez circuit?
I've seen a couple of them.
I looked at it the other day, because Brandon and a few others mentioned that it was similar to what I was doing with the Bedini flyback thing.
Yeah.
And I looked at the Carlos Benitez circuit, and it's similar.
Yeah, there's a lot of similarities in a lot of these devices. They're all working off the same principles.
But the load, on the Bedina's, the Carlos Bedina's thing, the load is in the middle, in the center of the two batteries. And the one I did is, there's two loads and two batteries, and they're not in the same place in the circuit. They're in different places.
Yeah, he had quite a few different setups.
Oh, what, the Carlos Benitez thing is?
Yeah.
There's multiple ways of doing it.
Yeah, he had a whole bunch of different setups.
I didn't know that.
Yeah, he had a few of them. Also the no lens, what do you call that? Motor coil. He had basically the motor coil, how it's attached on both ends. Well,
I was looking at the one with the two batteries that he has. Load in the middle. He was taking a 48-volt battery bank and a let's say a 24-volt battery bank to a 12-volt battery bank. He was dumping the higher potential to the lower potential and putting the load in the middle of that path, getting free. As he's moving the energy from the 24-volt bank to the 12-volt bank.
Right.
The load's in the middle, and he's getting free locomotion in the process of transferring the power from one battery bank to the other.
Yeah.
And then he would switch it to go back the other way.
Right.
It's similar to what my device does, but it switches every pulse. It's
actually,
pulse.
Rick Friedrich.
It goes back the other way each pulse. It doesn't wait any amount of time. Right?
Yeah, Rick Friedrich had a good. Rick Friedrich had a really good video. He was talking about the Carlos Benitez switching system. Where he had actually.
Yeah, when I was watching that video a few years back, but back then I didn't really understand too much.
What was it called? Loving Paths, selfish. What was it called? Loving Paths, selfish something.
I remember that. Yeah, he had
Yeah.
Came up with an anagram or something.
Yeah, but his system, I believe, had 4 batteries. Then he had another system, I believe, that had 6 or 8 batteries in it. There's just a way of switching it between, certain current potentials, 48 volts down to 12, and then vice versa. He would switch to combination.
Yeah, see, I'm not using the potential I'm not using a higher potential from one battery to go to another. That's not what my system's doing at all.
No, because you're going through the inductor.
Yeah, the higher potential is coming from the
that's what it was. Loving Paths, selfish circuits. Thanks, Reaper. Yeah, loving paths, selfish circuits.
But that's an interesting thought, to be able to transfer power from one battery to the other, not through pulses, but through straight constant DC.
Yeah.
and put the load in the middle. That I never would have thought of that, but that's an obvious thought that people should think of, obviously.
Yeah. Yes, even goes back to what Tom Bearden was saying. You can sacrifice power for switching, but the free energy, you shouldn't have to put power in to get that free energy. If you get the switching done correctly, you don't have to put much power into the system with any at all. So, yeah.
What did you buy, Anthony? What did he buy there? What's he talking about?
Oh,
The Carlos Medina's device?
maybe. I didn't elaborate on that one. High voltage pulse. Oh, he's talking about the high voltage.
Oh,
pulse.
that thing. Yeah.
Yeah.
Those things are cool. I have a few of those.
So 10 pulses.
Never did anything with them, but
yeah. So what the idea with this thing is, I have to pulse this very fast. Now, if I put a steady DC on it, you will pull at 3 volts. It'll pull 2 amps. So the idea is to pulse the power going into this thing without drawing a lot of amps.
will it still give you the arc and the on the output if you pulse it?
Yeah. Joe Layden says it will. Yeah.
Well, that's all you need.
Yeah. So I'm going to pulse this using my pulse.
The Ark of the Covenant.
Yeah, and then dump this into step down transformer. Let's see what happens. My
People keep asking, what is the Ark of the Covenant? Well, it's an arc, right?
It's a capacitor. So
it's an electrical arc.
It's
got something to do with electrical arcs.
Well, it's a capacitor discharge circuit. It's like a tank circuit. So what will happen inside the capacitor? The gold and all the dielectric material that was built in this box, okay, and then you have the 2 arcs in the middle, and over time that energy would build up inside and create a static potential between the 2 arcs. And when
that's what I was
high
saying.
enough, when it built up
the
high enough,
2 bird wings touching right at the spark gap.
And then eventually it would discharge, the power would drop down, and then it would build up.
Why was it? They saying that thing was killing people. Really, that kind of voltage was coming off of that thing?
You know what? That's cryptic stuff within the Bible, but it was.
That's just fear. They're trying to scare people away from it.
I think it could have had some kind of radiation coming off it.
Well, a TV capacitor can kill you. I mean, if you touch it.
Oh yeah.
So, man.
So maybe it was creating.
You can stop your heart. It can stop your heart. That's for sure.
Oh, you get 200,000-300,000 volts going through you. That it's not going to feel good, right?
But they say that if you don't discharge those old TV capacitors and you accidentally touch it, that they say it will stop your heart. You can die if nobody's there to resuscitate you.
Oh yeah, you got a few thousand volts. It takes 7 milliamps to stop your heart.
7 milliamps?
Yeah, very low. Doesn't take much. Yeah, 7 milliamps. Very little current takes to stop your heart. So if you're getting hit with, 20 or 30,000 volts, because I had a ceramic capacitor was rated at 15 kVA. I shorted myself to it, and it knocked me off the chair. Oh, almost knocked me off the chair. But it felt like somebody took a baseball bat right to my chest. I felt it right here. Oh man. I'm like, oh. I'm like, that didn't feel good.
Did that just happen?
That did not feel good. I did not like that. That hurt. So, boys and girls, discharge your capacitors before you put them away. I dead shorted. I grabbed both ends like this. And hit me.
How many volts was it again?
15 kVA.
Oh yeah, Jesus.
Oh.
And maybe you don't need many joules to feel that way.
Yeah, it had a small capacitance. If it had a higher, oh my god, yeah, 1 hand rule. Thanks. I didn't know that back then. Yeah.
I got hit by 50 milliamps and 600 volts.
It hurts. It really freaking hurts. Like I've had discharges off the freaking car door getting out of the car, that
You could
just
have
freaking hurt.
thick rubber shoes on, and that's not going to save you. It'll go from one hand out the other, not even touch your feet. You're going to get just as screwed up.
Oh yeah. Like I said, I was, just in my socks, sitting on the chair. I grabbed that ceramic capacitor and boom, just hit you.
If you got your left hand grounded and your right hand touching the pulse, it's going to go right through your neck, out the other end.
Oh,
That's what happened to me.
I learned a big lesson with that. Freaking.
If I was barefoot, it would have gone through my hand down my feet. But if you got insulated shoes, it'll go from one hand out the other if you're grounded.
When I grabbed the one that I did, it went through my arms, through my chest, and back to the other.
Right. Because you grounded one with one hand touching the ground, the other hand hit the positive. That's why.
Like, oh my God.
Now you look at capacitors differently.
Yes, I always discharge my capacitors after I'm done every night, just for that reason. Because that day, that was a lesson. That was a lesson. And I don't want to do that again. Yeah,
but we're going to do it anyway. We're going to mess around with high voltage. It seems to be our flaw. We see danger when we go right towards it, like a moth to a flame.
Oh, of course. That's just human nature. But like for me, it's like, okay, I've been zapped by 200 volts, 300 volts. That's not bad. You get into the kilovolt range, that's an entirely different experience. So yeah, you really respect electricity after an event like that. But yeah, some people, well, I wonder how many people every day get killed by electricity. I should look that up.
It's not that common. You have to really be in the perfect scenario to die from electrocution. I mean,
I've seen some videos of people get electrocuted up on the poles. Oh my God, it's scary. Like we're talking fried chicken. Like literally.
Line workers?
Yeah, well, no, just people going up on the poles. Like I've seen this video. It must have been from like.
Oh, if they're not line workers, then they don't know what they're doing. Yeah.
Oh my God, I've seen animals get fried. I've seen a couple bears go up and.
It's because they're touching the ground wire.
Oh man, poor animals. They just fry. Unbelievable.
Birds can sit on that hotline all day long because they're not touching the ground.
Yeah, I know. That's the crazy part. Like,
but then they fly off and they're charged,
Yeah.
And then they touch the ground later and they die.
Yeah.
Sometimes, yeah. If they're not, in the air long enough or whatever.
Or they touch water. Yeah. Yeah, I never thought about that one.
I think the line workers, they have to.
They're grounded.
They have a resistor to slowly discharge themselves.
Yeah,
before
they have this line that's on their body that they attach to the main ground of the pole. Because even a static charge on your body can fry you, right? Yeah, plastic.
So No, they're not grounded at all when they're up there. It's when they get off the line.
Yeah, sorry. It's a plastic pole that's a test probe. Keeps the skin and oil away from the probe, or the high voltage will flow to the oil. Yeah. So.
Right before they get on the chopper, they have to use that plastic pole that Anthony's talking about.
Right.
To drain them, to drain their body.
Discharge themselves. Yeah.
It's got a resistor on it, so it doesn't drain too fast, and they don't feel it. And they don't die from the sudden discharge to their body.
Right.
And I guess the helicopter is receiving the charge.
Well, they have the static plates. I know the jetliners have them. The static plates. They're these round plates. They're about 8 inches in diameter. They're all over the plane, and they're because when they fly through the air, they collect static discharge.
So how did they get rid of it?
I guess they have a method. They have a method of discharging that static electricity inside the engine.
Oh, they use it like they put it under load or something.
I don't know. They dump it into something. I know I should ask them.
Because they're in the air. They got no way to ground it out.
Right. Yeah. So they have some kind of method of grounding it, maybe into a capacitor bank on board the plane. Yeah.
Maybe they put it into a dump load or something, or a resistor.
Yeah. But it's pretty interesting because I wondered when I was years ago.
They could do what you said, put it into capacitor because they need to create 2 poles. All they have is 1 pole from that static charge, right?
Yeah.
So they could put the positive from the static into a capacitor bank, and then they can create their negative from there, and then they can put it through a load, dump it.
Yeah.
I guess. I don't know.
Yeah, it's pretty interesting because like those planes, they build up a huge static potential on the bottom airframe while they're flying.
Right, and they got to be able to get rid of that somehow.
Yeah. Yeah. They discharge it somewhere inside the plane or into a bank or short it out to the actual frame of the plane somehow.
I was thinking, since it's just a positive charge, they don't have a negative. But if you put that positive charge to a positive terminal of a battery,
Yeah.
and then a diode, and then you can create your negative like that by channeling it in one direction. Then you create a negative, and now you can dump it because you have the 2 poles. Now you can actually use the energy, or don't use it, just dump it into a resistor.
I guess you really would have to worry about it because you get the static potential near jet fuel. That could be catastrophic.
The whole of the plane is the positive, right?
Yeah.
Where's the negative on this? It's the rest of the environment is the negative.
Yeah, they'd have to. Yeah. That's a really good question. I should look into that. Because I remember years ago when I worked at the airport, I noticed these static planes. I asked the guy what it was because it was for static discharge. Well, it flies through the air and collects static electricity.
It's a buildup of positive flow.
Yeah, positive ions in the air just gravitate to these metal plates and they accumulate there. Then it's
because they got nowhere to, these positive ions got nowhere for themselves to ground out. That's why they're building up.
Exactly. Yeah. Yeah. And the higher you go, the higher the potential is. Right. Pretty interesting stuff. Yeah, static seems to be a really huge component. A lot of the stuff that goes back to heavy side, orgone energy.
The jet engine.
Chris is saying that there's a resistor in the plane.
In the jet engine. Well, it's got a coil. The coil has resistance, right?
Yeah, maybe it's discharging through the engine itself.
Think that's safe?
I guess it's working. I guess it's working.
I don't know if I would do that.
Up. I guess you would know pretty fast.
Oil would
blowing up everywhere. Right?
Oh, wait a minute. The engine's a turbine. It's gas.
Yeah. Well, it's running off. Well, it's running off kerosene. Right?
Well, I'm definitely not a mechanic.
Yeah,
I got no mechanical skills.
It's kind of a neat experience working around those big jetliners.
You got to have mechanical skills for that, man.
The one thing they have in it is pretty interesting is this unit right at the back tail. They call it the EPU, the auxiliary power unit that powers the plane. You can actually make the plane cruise without the big engines. They call it the EPU. It also provides a lot of the electrical power on board the plane.
It provides thrust?
It is a turbine engine, yeah. It can provide some
it's another turbine.
Yeah, it's another turbine. It's right at the back.
Oh, the one in the back. Okay.
Yeah, that's called the EPU. And that provides a lot of the electrical power for the systems on board the plane.
And that's also run by jet fuel.
Yeah.
I know one thing about these turbines, they have a way of making power, DC power.
Yeah, what it's called the RAD system.
Yeah, that
So
thing. Yeah.
if they're flying and all of a sudden they lose power by the turbine engines, right underneath the main wings, where the landing gear is, this little pod comes down it flips down and it's got a propeller on it. And that propeller is called a RAD system. It's an electrical generator, like a windmill, high-speed windmill. But they'll provide enough electrical power to keep the plane in control.
No, I mean in the actual turbine, the when the fuel is used inside the turbine, the turbine's rod generates generates high amperage, low voltage DC.
Oh yeah.
And they use that to
Power the hydraulics and all that stuff.
to condition the fuel.
Yeah. Condition
with the DC.
They also run the hydraulics in the plane.
Yeah, and whatever, they use that to make power for the plane as well, and also it does something to the fuel lines. It like cools it down or something.
Yeah.
I don't know, but they use all that power that being created off the burning of the jet fuel through the turbine, and on the circumference of the turbine, that ring that's doing the burning has a bunch of DC power on it from that reaction.
Interesting.
It's something like that. I don't know the specifics, but that's what's going on, and they harness that.
Yeah, they're pretty advanced now. These engines they're making are pretty advanced.
You got to wonder how they get those lights in the front, those bright lights in the front of those 747s. That takes a lot of watts, man. And those things are running for 9 hours in flight. That's not being powered by batteries. Those batteries would have been dead by now.
No, it's
and they don't have a generator inside there running nowhere. It's the generator is the turbine.
Yeah, it is. Yeah, provides all the power for the lights.
They don't actually have a separate generator doing the electric. It's coming from the turbine.
They have the APU at the back.
That's the same thing. All the I guess that's where they're getting the power from. But they could, any one of those turbines is creating the DC on that ring where the fuel is being burnt and sucked through the turbine.
Yeah.
That ring, the copper ring or whatever that ring's made out of, titanium or whatever, it's putting out low voltage, high amperage DC.
Yeah.
Which is very convenient, being low voltage. You're not gonna burn out anything with it, like as far as electronics goes.
Well,
that's very convenient.
Yeah, it's using the power wisely on the plane. Yeah, they come a long way with those jets. They're pretty amazing. Like just still the sheer size of those things, just being on the ground right beside one of those jetliners. You're looking up at the thing, and the weight was at 450 tons. An A380 Airbus. They weigh almost 500 tons. And I'm looking up at this damn thing, and I'm going, this freaking thing flies. Like, just because it's so enormous. Like when I stand, the main tires at where the wings are, they're friggin' almost 5.5 feet tall. And they have the big ones have 12 tires. And then the front landing gear at the front, the tires are the same size as the one on my car. So it shows all the weights on that back, and almost next to no weight is on the front. It's really weird. It's so bizarre because you're looking at the scale of the damn thing. It's so big.
Is there any reason why they don't? Because right now they run these jets or planes. They run them off of hydrocarbon, right? Like carbon and hydrogen.
It's a kerosene. They're running
right. So why don't they run it off of pure hydrogen?
Well, they're experimenting with that, but still, you got the safety factor too, right?
What, they're worried about explosion?
Well,
as if the carbon is going to help limit that risk.
Well, the problem, with the hydrogen, it's under a cryogenic type, high pressure container, right? It's in a liquid form.
So having
So,
carbon bonded to it, you can get away with less compression.
well, the only way you can do hydrogen like that is called a hydride, metal hydride. And hydride material, they use in nuclear bombs. But the hydride, if they make it more available, cheaper, you can make basically a non-pressurized fuel tank for hydrogen. It'll actually absorb hydrogen like water does a sponge, right? Where the sponge
So I'm talking about pure hydrogen, no carbon.
Yeah, that's right. We're talking pure hydrogen. So the safest way is using this metal hydride. They use them in nuclear bombs. That's where they store the hydrogen. So this hydride, in order to release the hydrogen gas, all you have to do is heat it up. As soon as you heat it up, the gas will actually come off the sponge or the hydride, and then you can use it at will.
Oh, I heard about that.
Yeah, it's called metal hydride.
The sponge thing with the hydrogen.
Yeah, it's called metal hydride. But
that's the new thing that they're trying to do now, right?
Well, it's not new. It's a controlled substance. That's the problem right now. You can't go out and buy this stuff.
Oh.
It's controlled by the government because they use it in nuclear bombs.
Mm.
So since they make it available to industry, then they can make the hydrogen tanks that are not pressurized. And the great thing about these tanks, there's one guy that made them, says I could shoot 22 into the side of the tank and it won't blow up because the hydrogen's not compressed. It's not in a compressed state.
It's a sponge. Yeah.
It's sucked up like a sponge. Says the only time it'll become combustible is as soon as you add a little bit of heat to it, the gas comes out of the hydride. Then it's combustible. So until that material becomes available to industry, then yeah, we could do something with it for sure. You can make.
So you're saying commercial airlines cannot run off of hydrogen liquid at the moment?
No, it's not feasible
because they can't compress it or keep it on board.
Well, it's under cryogenic, right? It's pressurized.
And that doesn't work for a plane.
No, it's the system's too big, it's too bulky, there's too much involved in it to keep it in a cryogenic state. It's just not feasible to do it that way. That's why they've been using the.
So it's on. They have to wait till they find a way to make liquid hydrogen stay liquid without pressure.
So now, if you were able to come up with a hydride tank that's non-cryogenic and 100% safe, and it won't blow up if you crash. That's the ideal.
I see what you're getting at.
Now you make
hydride gel or whatever.
Yeah, all you have to do is just warm it up, and then the hydrogen comes off it like a steam. So if you were to make that for a car, okay, well now having a hydrogen car is totally feasible because now you can store the hydrogen, and it doesn't have to be cryogenically stored. You don't have to worry about the tank blowing up on you if you get into a car accident. Be 100% feasible at that point, but problem is they haven't made it commercially available, and if it does come out, it's so astronomically expensive that nobody would be able to afford it. It costs you 10 grand just for the tank.
So we're back to energy storage technology.
Yep.
I mean, like electrical storage energy instead of fossil, or instead of the other type of energy known as hydrogen.
Yeah, I seen a really good video the other night. Actually, I forgot to tell you on the Joe Cell. They had a really good interview with Joe. Oh, nobody knows what his last name is.
Recent or old one?
No, it's an old one. He lives in Australia. I don't even know if he's still alive. But his engine worked. It was incredible.
You know what's ironic about the Joe Cell? He said it was a hydrogen device, right?
Yeah, it changed the state of the water, like the plasmoidal type technology.
Now, check this out. Check out these coincidences with hydrogen here. Aluminum is packed with hydrogen. And for the Joe Cell to work, it has to be an aluminum engine block.
Yeah.
And you also have to use an aluminum tube going to the intake Has to be aluminum.
Yeah,
It can't be any other metal.
that's right. And it's
What does
gotta
that
be
tell
aluminum.
you?
Yeah,
Aluminum is packed with hydrogen.
exactly. That's where
You
a
can
lot of
take a piece of
power.
aluminum, mix it with, I think, hydrochloric acid or something, and it releases hydrogen like crazy.
Yeah, yeah. I think the fact that
I think that's ironic.
he built so many cars. He built over 30 cars. He said at that time. He said he had over 30 cars converted over to his system.
I think the Joe cell is somehow it's tapping into the hydrogen state of the engine block, of the aluminum engine block, and aluminum is full of hydrogen.
Yeah. Yeah.
It's got something to do with the hydrogen in the aluminum block. The engine block is aluminum.
Yeah, it's the state of matter. He got it into a plasma, right?
And let's not forget, hydrogen and aluminum are like the same thing. They're full of, there's lots of hydrogen in a piece of aluminum.
Yeah, he did some pretty cool stuff. He also did some really cool water filtration systems just by using magnets.
I didn't see that.
Yeah, he did some really neat things where he just arranged the magnets in a certain way on an aluminum tube. You put dirty water in one end, clean water would come out the other side. You would take the water and drink it. And it was perfect.
That's great.
Clean water.
You gotta see that one.
Yeah, it's a very hard video to find. Very hard video to find. I seen it. I was actually somebody sent me.
Just using magnets?
Yep.
And tubes?
And aluminum tubes.
Aluminum again. Here we are with the aluminum.
Yep.
The hydrogen tubes.
Something.
I mean, aluminum is hydrogen. I don't know the formula for aluminum, but I bet you if you look up the formula for aluminum, I bet you there's a bunch of hydrogen in there.
Yeah. Oh, there is. He was using the ring magnets that you get from speakers, the giant ring magnets. He's using those and then arranging them in certain ways, positive to positive, negative, negative. And he had a special arrangement. And when he put that over the metal tube, you just have to pump water in one side, and on the other side, it would come out pure water. Like we're talking
That's
like toilet bowl water you could put in. No, I'm serious. And he would drink it right in front of everybody. Here, I'll put it through my
that kind of stuff needs to get out, man. That's.
Oh, he was hiding there for a while. He was being threatened big time. Big time.
Why? Yeah. Why? He's purifying water. Why would you be?
He was getting threatened with his gas thing, and oh my God, he took. Oh yeah, he had to go hide for a while. That the oil companies tried to make him cease and desist, yada yada. If you don't, you're gonna get knocked off. He was getting threats. Oh yeah, they were trying to steal his cars. Oh yeah, they were going after him big time. Let's go back in early '90s. This was going on years ago, early mid '90s. Yeah, they were going after him big time.
There's the formula for aluminum. Look at all those hydrogens.
There we go.
See all the H's? H3, H3, H3. Some carbon.
Well, carbon's
nitrogen.
Yep.
So.
Anyways, Mike, we're getting to the top of the hour here. I'm going to call it quits for the night. Getting all tired here. Yeah, another great show. We will do this again next Friday. Hopefully, I'll have my setup done where I can maybe do a demo. And Gerald's going to be working on his stuff. We do live shows every Friday night, 9 p.m. Eastern. Everybody, Anthony, Stephen, M4GNT, thank you. We'll see everybody next week. Mike, have a good one. Thanks.
See you, Mike. See you guys.
For your company. And we'll see everybody next week. Take care.
See you, Anthony.
Take care.